All right. So to recap, we had done the same problem using the Euler method with the crude step length of 0.5, and then the Euler method with the final step length of 0.1, and then the RK2 method with the step length of 0.5. So the important thing to note is between these two curves with the same step length, the higher order method gets you better accuracy. Now we are going to try fourth order method and see where this falls on this plot. Okay, so that is where we stand. So going back to RK4 spreadsheet, I'm going to delete this column because we are going to compute this, edit my column heading to RK4, and if I look at the method, it is summation of Aj, Kj, and there are 4 terms. J runs from 1 to 4. So I have to have a K1, K2, K3, K4, and I also have to have A1, A2, A3, A4. So there are 4 columns that we have to create for K, and then 4 cells that we have to enter the A values. Was that your question?
It's kind of.
Okay.
Would we want to also add column A?
You don't have to, it's just a single value. Why do you need a column? So let me redo this. So if you are here with me, okay, I'm going to delete the top row, add 2 columns, call them K3, K4, and of course for the first value, which is initial condition, we don't have those values. Okay, and then on the side here, I'm going to write A1, A2, A3, A4, 1 by 6, 2 by 6, 2 by 6, 1 by 6. Those who are trying, please try to keep up with me, and I want to cover 3 ideas today. One is this RK4, the other is solving second order ODEs using this method, and then systems of ODEs. So we are trying to address 3 concepts. We'll be a little rushed, but let's try. Okay, so you can delete all these K1 values. Okay, we'll start from scratch. So if you are here, we want to punch in the value of K1, which is the value of the function evaluated at point I. Let's try that first. So to visualize this process, here is I, here is I plus 1. We are here, our I point happens to be x equal to 0. This is x equal to h. So we have y of I equal to 1. That is part of the initial condition. We are trying to compute what is yi plus 1. That's our goal here. Okay, and we are doing this by dividing this into 4 segments. That's the RK4 method. Anyway, we have the formula, so you don't have to worry too much about how exactly the method was constructed. How would you evaluate K1? So, okay, first of all, what is your function? Just to keep it easy on the spreadsheet. Our function is this right answer. Okay, our function of x comma y, in this case, doesn't depend on y, it just depends on x, equal to minus 2 x cubed plus 12 x squared minus 20x plus 8.5. So I'll highlight this, make it a little bigger. Okay, maybe, yeah, that's fine. That is our function. K1 evaluated at the point I is going to be minus 2 multiplied by the previous row x value cubed plus 12 times f3 squared minus 20 times f3 plus 8.5.
said the reason why it doesn't depend on y is there's not a y
Yep.
variable in there.
It just isn't there. We'll do an example where there is one. In fact, your homework has one problem like that. So go ahead, compute K2. What is K2? K2 is the same function evaluated at x plus h and y plus half K1h. For our problem, this part doesn't come into play in this case today, but this comes into play. You have to evaluate 0 plus half h. So what you would do is to write -2 times open bracket. I have this plus what is my step length? 0.5. Okay, let me fill out 0.5. Right. So I have -2 multiplied by x plus half times h cube. So I'm going to copy this expression here. That's going to be useful because next time that is plus 12 times x squared minus 20 times x plus 8.5. So let me put a screenshot of this here. K2 value, this is the screenshot. I'll give you a minute to get it slow and steady. You get 4.821875, it means we are on the right track. For the exam, you can take it with 99% certainty that RK4 will appear on the test. I did give myself 1% leeway, but 99% guarantee that RK4 will appear on the test. As a word problem, you'll have to read the problem and then solve it using the RK4 method. So please practice. So that is K2. Okay, let me move this. Let me move this and also write it here. Just write it here. This is K2. Those who are trying, are you able to get?
Yes.
Yes. Yes. Richard. Yes. Jeffrey. Trying. Okay. I'll give you half a more minute. Try again. Like just try to type it. Type up what I have put here. Just delete what you have. Put this in so that you can see how this goes on. Yeah.
So is R3 going to be the same?
Yes, in our case, in this example, this is going to also be the same value K3 because we don't have any y dependence. If you have a dependence on the y, that is, if this function also has some y cube terms, etc., this will be different. So those who are done with K2, he just asked the question, will our K3 value be the same? If you have the same x argument and you don't have any dependence on y, it will be the same. Okay, so to get K3, you just go here, copy the text of this formula, go out here and paste it. I didn't say copy the cell and put it there. Copy this text and put it in the next cell. We copy the text of the formula. what I strongly suggest for those who are not trying at the moment or not able to keep up, this is getting recorded. So hopefully when you watch the video again, the screen share will do this step by step. So I suggest that you do it at home. If you don't practice this, you can't do this on paper in the exam. Okay, so this I can't emphasize it anymore, very important. So this is K2, also K3 in this case. Are you able to get these values? Brandon? No? Where are you stuck? Okay. I mean, typing up this formula requires you to be a little savvy with Excel. That is, you are taking F3, the value here, and then to that you are adding half H, H being the step length, half of the step length, which is 0.5, and then I put these two dollar signs so that the value of the step length is locked in place. It's the same cell that is referred each time, F1. So again, it also requires you to be a little familiar with Excel, okay? How do you do K4? No, it's not same as K1. It is evaluated at Xi plus H. So K2, K3 were evaluated at Xi plus half H. If you take this formula, all you have to do is get rid of this half to get K4. Okay, so do that. Copy the text of the formula, put it in the next cell, and carefully remove that half factor. Carefully remove the half factor before the F1. Wherever half F1 appears, remove the half, and you're there. So I'm going to take a screenshot. So this is K4. This is K4. It doesn't have half. This is Xi plus H. Xi plus half H. Okay. So you have K2, K3. Let me put this next to here. This is K4. Those who are not able to follow or not trying at the moment, suppose you had these 4 values, can you at least tell me what's the next step? Those who are not trying or not able to get these numbers exactly. What will be the next step if you have K1, K2, K3 values, K3, K4 values? Trade. Look at this expression. You need these K1 values, which you have now. What's the next step? Multiply them with the weightage factors, add them up, and add it to your previous value. That is yi being the current value, and then this is the new term, so that you go from here to here. That makes sense or not? That is, you are here, yi is here. Okay, this is sort of like delta yi. This is delta yi, the change in yi that you are now computing. You have, if you have K1, K2, K3, and 4 values, all you have to do is multiply by the weightage factors, add them up together, and add it to yi. Okay, that is what we are going to do. We need to take K1, multiply it by A1. So first step, add the yi plus A1, freeze it, multiplied by K1 plus A2, freeze it, multiplied by K2 plus A3, freeze it, multiplied by K3 plus A4, freeze it, multiplied by K4. So let me take a screenshot of that. So this 5.4375 is the result of this calculation. It just take A1, K1 summation, that is the 4 terms here, 1, 2, 3, 4. So if I write it here, A1, K1 plus A2, K2 plus A3, K3 plus A4, K4, that expression is right here. Sorry, that expression yi plus that expression is right here.
So would our yi value be the same as K1?
No, yi value is whatever the current value of x is, which is 0, corresponding yi value is 1. So it's the previous row. So see here. See here, it is K3, to reduce the resolution even more. It is K3 plus the summation.
You don't go for K4. I'm doing it.
Maybe, yeah. All right. What are the values people are getting for K4?
I also got one.
Yeah.
Okay. All right. So most of us are getting that. So now are we getting 5.4375 for the value of y evaluated at 0.5? That is, here you are, which is this point is given. What we are computing now is y of I plus 1 equal to 5.4375. Are people getting this?
Yes.
Yes. Jeffrey?
Yeah.
Yeah. Okay. So if you did all your formula punching correctly, you would be able to drag it down to the next row and so on. And the reason I put this $sign is to make sure that when you drag it to subsequent rows, F1 doesn't become F2. F1 has to stay F1 all the time. That's why we are putting the $sign to lock its value, or not value, but lock its position, so that you are always referring to cell F1. Yeah.
So for the RK4, are we not multiplying that summation by H? Your step length?
Maybe I wrote down the formula wrong.
Yeah, I think we're supposed to put that by eight. That's what we have in those two guys.
Yeah, I left out this formula, so it should appear here. So now I have to go and modify my cell here. So I have to multiply by H being F1 multiplication, and I have to lock the F1 sign, $. Oh, look at that. So let me take the screenshot again. All right, thank you. So I missed the step length F1. So if I put that in, the value I would be getting is not 5.43, it's actually 3.21875, which is pretty much the value of the exact solution. yi plus 1 equal to 3.2188. Okay. And my exact solution at that point is already available, ready to go. And the difference is minuscule. Is practically round off it. Okay, so once you are sure about this single row of calculation, which we are now sure of, thank you for the catch, you can drag it down to the next row. So I'll give you a minute to get the first row right, and then try dragging it all the way down. Yeah.
What did you change in the RK4 to give you the value?
So when I was writing down the formula from the book, I forgot to put the h, which has to be there. So it's like if you take the slope, this term here is like the average slope. Slope multiplied by h. That's what gives me the increment, right? So I forgot to write the h.
But where in the, I'm saying, I guess.
Oh, I have to, yeah. So if you see here, in this bottom picture, h is cell F1 multiplied by the summation. So we are fairly sure that we did the first row correct. We just drag it down all the way to the bottom, and each time it seems like our error is like it's negligible. It's almost zero. We are getting the exact solution, more or less, with a step length of 0.5 with the RK4 method. So to close out the discussion, we'll go here, add the RK4 solution to this plot so that you can see them together in one place. All right, so I'm going to remove this series of Euler 0.1 so that you have 4 curves here. Take a pause from writing. You have 4 curves. The blue curve is, sorry, the exact solution is right here. It's this curve. I'm a little colorblind, so forgive me if I.
They both look blue, they're just slightly off.
Yeah, no, I'm really little colorblind, so I might be off base on this. So let me use my pointer. So this is the sorry. So this is the Euler method with a crude step of 0.5. This is the RK2 method with a crude step of 0.5. This is the RK4 method, which has a very crude step of 0.5. I'm sorry. Yeah. And then you have the exact solution, which has very fine resolution. So what is your takeaway from this? If I give you this plot and ask you to write a 1-sentence inference, what will you write?
The RK4 method is the most accurate method given,
Got it.
even though it has a crude step length.
For the same step length, quality or accuracy improves with the order of your approximation of the slope. That's what the RK4 method does. So for many practical engineering problems, we don't bother even to look up the Euler methods or RK2 or lower order methods. RK4 is a very nice balance between computational effort and the gain or accuracy that you can achieve. So it's not a very complicated method. It's 4 evaluations of the function, but it gives you excellent accuracy. If you can go for 5th order, 6th order methods, it's just more evaluations or more effort, but the gain isn't much. How better can you get more than this, right? Why do you want to do? There are very specialized applications in which people do this. For example, space applications like predicting trajectories of asteroids or satellites or launch vehicles. If you travel millions and millions of miles, then any error that you make will slowly catch up. So only in such cases we need higher order techniques. For most practical engineering problems, RK4 is solid. Okay, so that's why I emphasize that a lot for your exam, that you should be competent in doing it. Okay. All right, so let's give people a second to catch up, clean up this spreadsheet. I'll be posting this anyway. And now we have learned how to solve first order ODEs. dy by dx equal to something, dy by dt equals something, whatever time or whatever your equation is, we have solved it first order. Now we want to use this knowledge and ask the question, I want to solve for second order equations or higher order equations. Or where do you encounter higher order ODEs? Examples.
Acceleration.
Acceleration. So if you write, erase this here. So your homework problem talks about getting the trajectory or position of a particle when the force or acceleration is given. So it talks about dv over dt equal to a function which may depend on velocity, it may depend on the position, and it may depend on time. So how do you solve this equation? This is in fact really d over dt of dx over dt equals f of x dx over dt and time, or d squared x over dt squared equal to f of x comma dx over dt and time. So you need two initial conditions. You need to know the position at time 0. You also need to know the velocity or speed at time 0. These are part of your initial conditions. So the goal now is shifting to how do I solve second order ODEs, and to learn second order, you should be able to make the leap to third order, fourth order. We are not going to discuss all those, but at least you will be able to think about it. So the problem in hand we are going to have is d squared x or d squared y over dt squared minus plus k squared y equal to 0. Okay, you can obtain an analytic solution for this. This is y of t equal to arbitrary constant times cos kt plus another constant times sin kt, where a and b are evaluated using the initial conditions. Y of 0, let's say, is a, and y dash of 0 is b. How do you reduce this problem to a problem that you can actually handle using what you learned so far? What you have learned so far is how to use RK4 method for a first order differential equation. How do you reduce this problem to what you know so that you can actually use it? If I take this equation, d squared y over dt squared is minus k squared y. I can generally write this is f of x comma y. Can't I? Just calling it a function of x and y, even though x doesn't appear here. If I make the substitution, dy by dt equal to z. If I make the substitution dy by dt equal to z, how does this equation reduce? This is d over dt of dy over dt equal to minus k squared y. Look at that. Tell me. Or what I was going to suggest is if you were to shift the dt squared in the denominator on the left side over to the numerator on the right side, and then divide by y on either side. No, we are not doing analytic integration. We are trying to set it up as a problem for which a numerical method can be applied. This is a easily integrable problem. Not every problem will be like this. So we want to prepare ourselves to apply RK4 method for any problem. I chose this because for this the exact solution is easy to get. So what is this equation? The derivative of dy over dt. Look at this and look at this. Tell me how they are related.
Lower equation is the derivative of the upper equation.
So it's like writing the derivative of z with respect to time is minus k squared y. So we'll call this equation 1. We'll call this equation 2. They are two ODEs. So you have replaced one second order differential equation with two first order equations, which you can solve using your RK4 technique. How do we solve? So I have my first equation, dy by dt equal to, I'll say a function 1 which depends on y, z and time. And then dz over dt is a second function f2 which depends on y, z and time. Notation is important because if I generalize it into this form, then I can start applying it for any problem and not just that problem. Tell me what is f1? No whispering, tell me loudly.
Is it just y plus z plus d? Put into our function.
Look at this problem and tell me what is f1, what is f2. What is on the right side of dy by dt equal to f1?
Z.
So f1 is simply z. What is f2?
Negative k squared y.
Correct. Negative k squared y. So then you have your initial conditions. Okay. Let's say our initial condition A is 1 and B is half. We're just making it up. Okay. So if y of 0 is 1, y of 0 is 1. What is y dashed? Y dashed is dy by dt at y equal to 0, or this is z at t equal to 0, which is equal to half. So z of 0 is half. So here you are having a system of two differential equations equivalently reduced to two first order ODEs. So instead of having one second order ODEs, we have two first order ODEs. Quick conceptual question. Suppose you had a fourth order differential equation. You go through the same substitution logic. How many differential equations will you end up with? How many first order equations will you end up with? 4. Whatever is the order, if this is nth order, you will end up with n differential equations. Yes.
Where did you get the 1 and 0 for y 0 equals 1 and z of 0 equals 1/2? Is that just from the
I gave values here.
that was just
I chose them. Yep. Are we clear about the setting of the problem so far? we took a second order ODE, we made the substitution. Whatever is your dependent variable, you take the first derivative of that, call it z, so that the equation itself reduces to dz over dt. So you end up with two equations. Now y and z are the two equations. Y and z must be solved simultaneously. What does that mean? Simultaneously. When I say they have to be solved simultaneously, what do you understand? Yeah,
We can't just do substitution.
this is about numerical methods, not analytic methods. So no substitutions. You are done with substitutions, you have arrived at this form. I'm saying you must solve them simultaneously. What does that even mean for you?
They are dependent on each other.
They are connected to each other. Like for example, the second equation is connected to the first equation. The first equation is connected to the second equation. So you have to, if you are here, if you are at a point in time, say call it ti. If you want to advance to ti plus 1, that is, if you want to advance the solution by step length delta t, you have to solve for both yi and zi, and yi plus 1 and zi plus 1. You can't do just one. You can't just treat them as individual variables. They are connected at the hip, meaning they are coupled. So you have to apply the RK4 method for equation 1 and equation 2 simultaneously, that is concurrent, and then get the value for the solution at the next point, update this, and so on. So that was your answer to the question you asked me the other day. If you have a problem that involves that looks like this, dv by dt, m dv by dt equal to minus f times b plus mg, something like this. This is on the surface, it looks like a first order ODE, and it is first order if you are interested only in speed. But if you want to know the position, you know that dx over dt equal to v. What is this? This is the definition of speed. The second line is nothing but Newton's law. Mass times acceleration equal to force. Okay, so now you have dx over dt equal to a function 1 which depends on position, speed, and time. dv over dt is another function f2 which depends on x, v, and time. So you can write f1 of xvt is v, f2 of xvt is minus f over m times v plus g. So to solve your homework problem, you have to apply this transformation, reduce this first order ODE in velocity, second order ODE in position to two simultaneous equations, and then go through the motions. So the spreadsheet we prepared together, which I will of course post on the canvas. If you take the spreadsheet, it's basically a template to solve one equation at a time. You just have to use the template twice to solve two equations at each step. Okay, so let's do this on hand. That is, I'm going to do this with you, and we'll try to get at least a few time steps computed. So I'm going to, this is my example related to the homework. So like a hint or a tip for the homework, but this is really the problem I want to solve at the moment. Okay. So I have y at time 0 and z at time 0. This is equal to 1, this is equal to half. Let me choose a step length of half a second. So to give it units, we'll call this 1 meter and 1 meter per half meter per second. So I have y at t plus delta t equal to y of t plus delta t multiplied by j equal to 1 to 4 aj aj. And then I have z at t plus delta t equal to z of t plus delta t multiplied by j equal to 1 to 4. I'll call this aj lj. Question. AJ values in this first line and in the second line are the same, true or false? AJ values are the same between the two equations, true or false?
AJ,
True. What do you say?
or AJ, yeah.
For AJ, true. Because AJ is not about the problem, it's about the method. So AJ values are what they are always. A1 is 1 by 6 equal to A4. A2 is 2 by 6 equal to A3. That won't change.
Can we use those, the A1 through A4 or whatever, can we use that for RK2 and for RK4?
No, if you want to keep it clutter free, I would just ask you to keep like a separate page for each method. The A1, A2 notation is specific or local to that method. Don't cross pollinate, you will end up with only confusion. All right, so this is a old school paper and pencil problem in the exam. So this is how I would approach it, okay? I know my delta t, I know everything in this equation. For time 0, I'm going to consider the first time step. So this is time 0 and this is time half a second, meaning t 0 plus half, okay? So how do I compute k1, k2, k3, k4? K1 is the value of function f1 evaluated at time 0, at y of time 0 and z of time 0. What is f1? Z evaluated at time 0, which is part of my initial condition, which is half a meter per second. K2 is the value of the function f1 evaluated at t plus half delta t and y at t plus half delta t. So I'm just going to write this t equals half a second, sorry, t equals half of half a second and y evaluated at the same value, z evaluated at the same value. Oh, wait, sorry. So this should be y evaluated at y plus delta t times k1 divided by 2. And then z at time 0 plus k. So we also need to compute Okay, all right. So we did K1, right? Let's do L1. L1 is the function f2 evaluated at time 0, y evaluated at time 0, z evaluated at time 0. What is f2? Minus k squared times y at 0, which is 1, and we'll choose a value for k. K should be 1 per second, correct? Yeah, 1 per second. So that this is simply minus 1 meter per second squared. K1 L1. So this is the simultaneously solving. That is, you have to kind of evaluate K1 L1 together, and then you would do K2 L2 together, K3 L3 together, and so on. Because why you have to do this together? This in K2, both y and z are going to figure. Okay, so you will need to have L1 also ready in order to update z, K1 ready in order to update y. Okay. So I'll give you a chance to catch up to here, and then we'll do K to L. More space. Are we up to date? I mean, part of up to here? Yes. So K2 would be the value of the function f1 evaluated at t plus half delta t, y1 at t plus delta t multiplied by k1 divided by 2, and then z1 at t plus delta t divided multiplied by L1 over 2. Check this against the RK4 formula. Am I writing it correctly? All I have done is extend it to include more variables on which this function depends. Okay, half K1 delta t, half L1 delta t. That looks correct. So in our case, what is this? Our f1 function has no dependence on time and y, it only depends on z. So this is z1 of time 0 plus delta t multiplied by L1 divided by 2. What is z1 of time 0? Half a meter per second plus delta t being half a second multiplied by L1 minus 1 meter per second squared divided by 2. So this is half minus a quarter. So this is 1 by 4 meter per second. K2. Tell me if you are able to follow this or get this. Yeah.
At the top of the board, the value per day, did we solve for that? or-
No, that is a parameter given in the problem.
Okay.
It's like the spring constant.
Okay.
these are given values. This is just like a spring constant. This is initial displacement. This is initial speed or velocity. You are doing a spring like an experiment. You would pull it apart, you would pull it back, that is your initial displacement. If you leave it with zero velocity, this is zero. If you give it a flick, that will be this value. This is your spring constant. Are we able to get this value? Am I correct? Like anyone has any other values that you got? Okay. So now go ahead and compute L2 right after you did L1. Sorry, K2. Or you could do the other way. You could do L2 first and then K2. But the thing is, you have to do them as a pair. So let's do L2. L2 equal to the function F2 evaluated at t plus half delta t, and then y of t plus half delta t multiplied by k1, and then z of t plus half delta t multiplied by L1. Our function F2 has dependence only on y, not on z and t. So this really simplifies to writing -1 times y. What is y of 0? Or I'll write y of 0 plus half delta t multiplied by k1. -1 multiplied by y of 0 being 1 meter plus half delta t being half a second. And what is k1? 1/2 meter per second. 1/2 meter per second. So that gives me -1 multiplied by 1 plus 1/8, right? 1 plus 1/8. That is 1.125. So this is -1.125 meters. L2.
That's right.
Yeah.
I'm a little behind, but for K2, shouldn't it be 3/4 meters per second? Because
Negative.
one times. Oh.
So you have K2 and L2 simultaneously calculated, just like you did K1 and L1. Think of it like this. You have the function y of t, z of t, and then t. They are necessary to compute K1, L1, which in turn are now necessary to compute K2, L2, and then K3, L3, and then K4, L4. All four, or all five actually, all five of these together determine the solution at the next step. So you have to go in this sequence. So go in this sequence. Don't jump to any later step before you do the previous step. Yes.
What happened to the negative k squared over here?
K is 1, so -1 squared. That's why I chose k equal to 1 to keep the numbers simple. Can I erase this part alone? So I'm going to create a small table here. At time 0, my y value is 1, z equal to 0. When I do K1, L1, what is K1? Can somebody tell me? 0.5? 0.5 meters, and L1 is -1 meter per second squared. And then I have K2, L2, K2 being 0.25, and L2 being minus 1.125 meter per. Yeah, it's just meter. So, yeah. Yeah. Now you compute K3, L3, then K4, L4. So that you will have all the numbers you need in one place, and then implementing the formula becomes easy. And then you implement this formula. Y of t plus delta t equal to y of t plus delta t multiplied by a1 k1, a2 k2 plus a3 k3 plus a4 k4. Like I said, you can take it for a near guarantee that you will be asked to do this type of a hand calculation for your exam. Yeah,
Why did the units change for K1 and K2?
if you look at
L1,
sorry,
and L1?
so I think I goofed up something in the unit. Let's check here. So when you do L2, it's F2. What is F2? F2 should have units of what? Meter per second squared. So I guess that was correct. Let's see what I missed here. I missed the unit on -1. Okay, this is -1 per second squared. So this will be meter per second squared. So this is 1.125 meter per second squared.
And our K1, shouldn't that be meters per second?
No, K1 is just Z. Z just has unit of length. See, your K1 is ultimately a function of, is F1 evaluated at some point. F1 is Z. Length has to have the unit meter. Okay. Shall we try K3, KL3? Main thing is, message for the day is to go in blocks. You have to do these two simultaneously. If you can't go in this way, you have to go this and then this and then this. If you had a third order ODE, you might have K1, L1, M1, K2, L2, M2, and so on. If you had a fourth order, K, L, M, maybe a possible N. Like you will have 4 such steps, and then you have to go together. Okay. Can you try K3, please? So I'm going to erase this K2 calculation and try to do K3. K3 is the function F1 executed at t plus half delta t, y1, y at t plus half times delta t multiplied by K2, and then z at t plus half times delta t multiplied by L2. Our function F1 has only z, so luckily for us, this simplifies to z of t plus half delta t multiplied by L2, or z of 0 plus half delta T multiplied by L2, which is there, yeah, minus 1.125 meter per second squared. So this is, what is D of 0? Half a meter per second plus half times delta T is half a second multiplied by minus 1.125 meter per second squared. So that gets me what? So this is 1 by 2 minus 1.125 divided by 4 meter per second.
21875.
Point, say that again,
21875.
2188 meter per second. So I'm going to write K3 is 0.2188 meter per second. I strongly recommend rewatching today's lecture on YouTube because number one, I'm still offended. My YouTube views are very low. Still not a YouTube personality, but whatever. But more importantly, I've kind of put a lot of concepts over on you, so you have to work out this again. Don't expect to know all this or grasp all this in one go. It's sort of not mind bending stuff, but it's tricky, a lot of steps. Okay. All right, L3 is the function f2 evaluated at t plus half delta t, the function y of t plus half delta t multiplied by k2, and z of t plus half delta t multiplied by L2. And our function f2 has only y dependence, so that's good, which means this is minus k, which is minus 1 per second squared multiplied by y of 0 plus half delta t multiplied by a2. A2 is 0.25. 0.25 meters. So if I put back with the units, minus 1 per second squared, y of 0 being 1 meter plus half of half a second multiplied by 0.25 meters. Something isn't adding up, right? What is the unit for K?
Shouldn't it be meters per second? Okay.
No, it is 1 meter per second.
No, K is, yeah, K is just meters. So I have meters.
That was K meters per second. The first one is just the initial, and our initial condition says it's 1/2 meters per second.
Oh, yeah, this has to be meter per second. Because Z is a speed. Z is a speed, so
You have it written K3 is meters per second.
yeah, yeah. So I'm going to write this is meter per second. Per second. So I'm going to get 1 plus 1 by 8, or this is minus 1.125 meter per second squared. That is L3. Of course, it must be the same. Minus 1.125 meter per second squared. Okay, So one last time, getting K4 and L4. So K3, L3. Let's do K4 and L4 here. So K4 is going to be the value of Z at 0 plus delta T multiplied by K3, which is half a meter per second plus half a second multiplied by 0.2188 meter per second. So this is 0.5 plus 0.1094 meters per second. The unit of heat. Yeah. Meter per second. I'm getting the units all mixed up.
Professor,
Yeah,
your L3, I think, was calculated slightly wrong. It would be 1 plus 1/16,
yeah, 1 plus 160.
which is negative 1.065.
Thank you. So what I'm going to do is try to pause here and let you work out the rest. I will post solution for this problem, like a handwritten solution that you can review, okay? Let's not, I clearly missed the step in the unit somewhere, so each time there is a confusion. Let me write it out as clearly as I can and post it on Canvas for you to review. But anyway, the key takeaway is you have to do a substitution like doing dz or dy by dt equal to z, which turns this into two differential equations. Sequentially solve them simultaneously, so updating both until you get the final answer using this formula. That is the overall routine for solving higher order ODEs, and for the exam I will not go beyond second order. So if you have the skill to do first order ODEs and second order ODEs, which is really two first order ODEs, that's what this is, will be okay. Okay. So what I owe you is to post handwritten solutions for this problem, which you can review from start to finish. Okay. Yeah.
So for the exam, when it comes to calculating our Ks and our Ls, could we just, I guess we still have to write the equation and then just write what it's equal to, so that way it would be like as fast as possible to get the steps done.
Yeah, I will, like the exam 2, I will allow the use of a computer or Excel. So you provide sufficient details and do the calculations using your Excel sheet, that is okay. But I want you to do this in hand, because as you saw today, doing this isn't straightforward. Trying to understand everything, you have to make a few mistakes, and to make those mistakes, you have to try it by hand. Then implement the same thing on Excel so that you can do a nice comparison between handwork and computer work. Okay. So for the remaining time, which we have 15 minutes, I have an off-campus engagement that I have to take off for, but my PhD student, Mr. Joel, is here. He is going to do an example problem related to systems of ODEs, right? Yeah, he's going to solve a problem related to solving something like this, except the system that he's choosing are not connected to a higher order differential equation. It's just two sets of equations, like a spring block system, like equation for two blocks that are coupled together by a spring or damping or something. So he's going to go through an example to wrap up today's lecture. Okay, so I'll see you guys on Thursday. Thank you. 12:45. They'll tell you.
Okay, so yeah, up to now we have done a lot of calculation, right? And in this section, unfortunately, we are doing the same, but for a system of linear equations.
Right, okay.
Okay. So system of ODE. So have you seen coupled pendulum, like pendulum connected using a string with a stiffness gauge? Have you seen this kind of problem? So if you start moving one pendulum, what happens to the other one? Will it stay stationary or it will move? It will move, right? Yeah. So these kind of problems, to solve these kind of problems, we need to solve coupled equation. So when you solve the equation of motion, you will get something like this. So here the variable is theta 1 and here the variable is theta 2. So when you solve this kind of problems, if you want to model this kind of situation, you need two equations. One for theta 1 and one for theta 2. Okay, and theta 1 is defined as omega 0 square, theta 1 minus k, theta 1 plus k, theta 2, and k is the stiffness factor, not one we see in the RK formula. And for the second one, we will get theta 2 plus minus k, theta 1. Okay. So this is a coupled equation, right? So the thing is like we need theta 1. We need to study how theta changes its time or theta function, right? What is constructed like so if you want to solve this first equation, theta 2. So if we need to solve the first equation, we need to know what is theta 2, right? And we get theta 2 from the second. So this is kind of simultaneous equation. We have to solve this together, and we have to follow the same method we just like see when Professor produced. So how we can like write a system of linear ODE? So a system of linear ODE can be written generally as this is like f1 is equal to f of f1 of x, sorry, x, y1, y2 up to yn. So this is a function of like y1, y2, and like up to yn. So initially we only saw like it's a fun like in RK4 method we only saw x of sorry f of x and y, right? But now it's a function of x, y1, y2 up to yn. And like we can write a system of equations like f2 is equal to dy2 by dx, which is a function of x, y1, y2 up to yn, and up to f. Sorry. F no x1, y1 up to yn. Okay. So the thing is like how we can solve this problem using RK4. So we just saw right like how to solve second order method. So how we are like solving second order method using RK4 method. Second order.
Oh, we have to split it into two first.
Yeah, we have to split into two first equation, first order equations, right? And here, like here, what we do is like if you know what is happening in RK4 method, if you like the thing is we have some equation, right? Like dy f1, like f of x and y, right? So this is the like general form, which is the primary form using RK4 method. So this is like if you have a curve like this, we will start from this point, find the slope. This is k1, right? The slope at the initial point, and we will find the slope at the midpoint. This is the interval h, or like x I plus 1. This is xi. So we will find two more slopes here, which is k2 and k3, right? At the midpoint, and we will find the slope at the end point, which is k4, and we will find the average like yi plus 1 is equal to yi plus 1 over 6 k1 plus 2 k2 plus 2 k3 plus k4, right? And you know how like how to define k1, k2, and k3 and k4, right? Yeah. So how we can solve this one? So if you are adding, this is actually y1 and this is x. Okay. So and this point here is actually a function of y1 and x. So this is the basic method you already see in RK4 method, right? But when you are adding one more thing, like which is y2, okay. So this like problem is like converted to a like S3D space, or like now it's a function of y1, y2, and x. So is it clear? So we have to solve like now the curve to like to study the system, we need y1, y2, and x. Okay. So like here we calculated K1, sorry, K1, K2, K3 and K4. So here with respect to Y2, we have to find what? L1, L2, L3 and L4. Okay, so that's what like Dr. Ramana just told you. So here we can do an example. So do I need to write the whole equation? So K1 is what? K1 is, we know like what is K1? How to find K1 the equation, which is f of x0, y0, y10 and y20, right? And L1 is f of x0, y10 and y20, right? Then we need K2. K2 is what? F of x0 plus, where like we are finding at the midpoint, right, of the interval. So x0 plus, yeah, h out, right? And y10 plus k1 h out, right? So y1 changes with k1. And the third thing is y2 of 0. Is it k1 or L1? It changes with L1, right? Because the slope of y2 is actually L1, right? So y2 0 plus L1h over 2. This is actually K2. Then L2 is f of the same thing. Okay. But this is actually F2. This is for F1. So, because we have two equations right now, which is like F1 and F2. So is it clear? So we can write like this, like the other terms, like K3 is F1 of x0 plus, again we are finding K3 at the midpoint. Y10 plus K2 h over 2, right? And this is y20 plus L2 h over 2. K4 will be F1 of x0 plus h, because it is at the end point, end of the interval, y10 plus K3 h over 2 and y20 plus L3 h over 2. We have to simultaneously write the L3 and L4 also, which is the same the term in the parenthesis, but with F2. We are finding for F2. Is it clear? Is it clear what we are trying to do? It's the same method, but for like two equations. Okay.
Is the K4 also h over 2 for the last things, or that's just?
Oh, sorry, it's supposed to be H. Sorry. This is actually 10. Thank you. Okay, so let's 5 more minutes. Let's do one example. It's actually from your text. So how we will solve this? How we can solve this? Because you know already know how to find K1, K2, K3, and K4, right? Then we can actually, if you know these terms from K1 to K4, we can write like F1, or we can find y1 of, sorry, yi plus 1 of, y1 of I plus 1 equals to yi plus 1 over 6 K1 plus 2 the over the terms times x, right? And you can do similarly for y2, right? So here the F1, like F1 will be, or like sorry, we have to find K1 to K4 and L1 to L4, right? So what is K1? K1 is simply f of x0, which is the initial point, right? X0, y10, y10 is 4, y10 and y20, which is f of 0, 4, 6, right? We have to find similarly L1. What is L1? F2. This is F1. This is F2, right? F2 of the same point, x0, y10 and y20, which is F2 of 0, 4, 6. Is it clear? Like, okay, then we have to find K2. F1 of 0 plus h by 2. What is h? 0.5, right? So 0 plus 0.5 over 2. Then y0 plus h by 2. So 4 plus 0.5 by 2 then 6 plus 0.5 by 2. Then L2 is same for F2. So is it clear how we are finding at least some method? You can use actually the Excel. You don't need to like do all this step. But is it clear how we are finding for a system of equations? We just need to find K1, K2, L1, L2, K3, K4, and L3, L4. Okay, and you can if you know all these things, how you can find the final solution? You can find y like the next point. If you know the initial point, the next point which is I plus 1 is equal to 1/6 K1 plus 2K2 plus 2K3 plus K4 times 7. If you do this, you can actually find the final solution. So like if you are using that for a like if you are using Excel, you just need y1, one column for y1, one column for y2, one column for x, and we need K1, L1. And because we need K1 and L1 to find K2 and L2, right? So we need extra columns for L1, L2, L3, and L4. Then it's the same, right? And you need 2 columns for RK for Y final, Y1 final, and Y2 final. Okay, so it's almost the time I guess. Right. Yeah, one more. Thank you.
Instead of the problem in the book.
Sorry? Yeah, it's the problem.
You know which example that was, what number example it is?
Yeah, it's example 25 point. 25 point. Yeah.
What page is that on?
715.
You said 45 points.
If you entered in.
That's why I didn't show up. We nobody had done. So. I'm not gonna sit here and waste some time before we talk about what should be done at this point. What we're gonna do later today. Independently. All right, now we just wait for another good here with this. Session up to meeting about. Yeah.
Yeah, I totally agree.
I don't know why she volunteered to be team lead. Study.
You don't have to stop. Right?
Yeah, it's a Zoom.